Hector here from helpmegraduate.com. Now we're going to do a very difficult example, a very hard exercise regarding limits and trigonometric functions, okay? And I thought I said we were going to pick up the pace a little bit with the exercises, so again, this is a real brain hassle. Like I've said in the past videos regarding trigonometric limits, the main issue with them is that they, number one, they require a lot of knowledge regarding theory and properties of trigonometric functions, the one that I mentioned in the trigonometric function properties video. You can click on it in the description. And number two, they ask for a lot of knowledge regarding notable trigonometric limits, okay? And number three, they require a lot of creativity and thinking out of the box regarding combining 1 and 2, okay? Meaning you have to combine the properties of trigonometric functions with notable trigonometric limits, okay? So in this particular example, well, here we go. A is a real number, and we have limit of x tending to a of sine of x minus sine of a, so this is a constant, over x minus a. So if we evaluate, as always, the first thing we have to do is evaluate. We're going to end up with sine of a minus sine of a over a minus a. And this is 0, and this is 0. So this is an indetermination, okay? So we have to work on the limit, okay? Because we have an indetermination, we have to work on it. So this is where the hard part comes from. What are we going to do to solve this limit? Well, I have to be honest with you, and when I see the exercise, at first I myself have kind of like a glance and try to figure out which of the alternatives I have to use to resolve the problem, okay? And I was like, well, maybe if we can add 1 or subtract 1, or maybe I can do the conjugate, maybe if I multiply here and there by a sin or a cos. And the main thing you have to keep in mind is the following, okay? Look at the exercise, okay? See which kind of trigonometric function you see in the limit, and using that, see how can you get that trigonometric function to look something like a notable limit, trigonometric limit, okay? So in this case, I have a sin. So I know that most likely I have to get this thing right here to look something like a trigonometric limit involving sin, okay? And the one that we know from a past video is this one right here, okay? Limit when x tends to whatever argument, okay, of sin of whatever argument over whatever equals 1, okay? I'm doing whatever here because it doesn't matter what the argument is, okay? You can label it as xo, and then xo right here, and then xo right here. Okay, it can be anything as long as this is consistent. As long as these two are consistent, okay, the property remains, okay? So since we have a sin right here, okay, we know that somehow we want the limit to look a little bit like this, okay? That's pretty much the hint. That's going to be the first property we're going to use regarding notable limits. The second property we're going to use is going to be regarding properties of trigonometric function. It's going to be this one, okay? The sin of two angles being added or subtracted, okay? Sin of x plus or minus a equals sin of x times cos of a plus or minus sin of a times cos of x. So you will ask, well, why are we using that property? There's no addition of angles right here. And you're right, there isn't. However, think of the following. Look at the exercise. Look at the exercise and look at the notable limit right here. Okay? Look at the exercise and look at the notable limit. Okay? We have to make sin look like it has an x minus a in the argument so that I can use this property. Okay? And the only way to do that is to incorporate something into the argument of x. So what we're going to do is add and subtract a in the argument of sin of x. Okay? So let's start with that. If it gets too long, I may have to split the video in two parts, okay? Because I'm trying to go as slow as possible, and I want to explain as most as I can. So, we're going to have limit of x tending to a are the following. On top, we're going to have sin of x minus a plus a minus sin of a over x minus a. And remember, this right here is 0, okay? So I'm just adding, I'm subtracting the same thing, okay? So that the argument remains unchanged. What I'm doing is rearranging it, rewriting it, because I want sin to have an argument that looks like x minus a, because if I achieve that, then I will be able to use this, okay? However, as you may have imagined, this also brings up a problem, because now I have this and this, okay? I'm going to have x minus a and plus a. So what I'm going to do next is separate them, okay, using this property right here, okay, and treating them as if this was one part and this was the other part, okay? This right here is going to act as x, and this right here is going to act as this a, okay? So that's what I'm going to do next. This equals to limit when x tends to a of, and what I'm going to do next, like I said, is use this property with these two, okay? These two. X minus a is going to be 1, and plus a is going to be the second one. So I'm going to end up with sin of x minus a times cos of a plus, because of the plus sign right here, sin of a cos of x minus a, okay? This right here is this being expanded with this property, okay? And then, of course, minus sin of a. All of this over x minus a. Now, I have to start looking for the notable limit, trigonometric limit, which is this one, okay? And I have to look at it in every single part of the equation, because as long as I'm able to simplify something, I will be able to get rid of the indetermination, okay? So, if you probably get a good glance at the limit, okay, take a quick look at it, we have been able to bring up the sin of x minus a in one place, right here. Taka, 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 taka. This is equivalent to 1. Okay? Because of this, because of the property. Okay, and this is demonstrated in a past video, like I said. This expression is equivalent to 1. However, I still have this plus and this minus. So that means that I still haven't been able to get rid of the indetermination in this part of the equation and in this part of the equation. Okay? So I have to work on it. Okay? I have to keep on working. That's what we're going to do in the next part of the video, because I think, yeah, let me check my timer. Yeah. I think it's about 9 minutes. So let's split it into 2 parts. Okay? I'm going to leave this, and I'm going in the next video. This will be on top.